Newton's laws are the basic laws of physics which has helped us over the decades to understand the behavior of many things around us. So, we must recall Newton's law as it holds great significance in engineering mechanics. Let's start with Newton's first law. It states that every body continues to be in a state of rest or uniform motion along the straight line unless it is acted upon by an unbalanced force. For example, a football stays still until someone kicks it, and it continues to move until someone stops it. So, the unbalanced force will make the ball to move or stop. Another example is a bicycle. If you apply the brakes, the cycle may stop, but you will be pushed forward in the direction of the motion. That is because of inertia of motion. So, any body will continue to be in state of rest or motion until an unbalanced force acts on it. That is about Newton's first law. Now, let us move on to Newton's second law. It states that the rate of change of momentum of a body is directly proportional to the force applied, and this change in momentum takes place in the direction of the applied force. So, the net force applied to a body produces a proportional acceleration. Also, the rate of change of momentum is inversely proportional to the mass of the body. For example, when you try to push an empty shopping cart, it will move very fast, whereas the loaded cart needs more push to move. In conclusion, Newton's second law provides explanation for the behavior of objects when the forces do not balance. The law states that unbalanced forces causes objects to accelerate with an acceleration that is directly proportional to the net force and inversely proportional to the mass. So, mathematically, it can be written as A is equal to F divided by M, or F is equal to ma. That is Newton's second law. Let's move on to Newton's third law. It is one of the popular laws. It states, for every action, there is an equal and opposite reaction of the same magnitude but in opposite direction. For example, if a ball is dropped on the floor, it will bounce back. The ball is doing some action on the floor and in turn, it will be pushed back up. This is the action-reaction pair. It can be observed in almost all the cases where the force is applied on an object. This is about Newton's third law. To sum up, we learnt about Newton's first law, which tells about how a body continues to move or stay still. Then we learn Newton's second law, which tells us F is equal to ma. And then finally, Newton's third law, which gives the very famous action-reaction pair. With this basics in place, we'll move on to different types of force in our next video. See you there.